Hey, hello everybody, what's up? Welcome to 3D Hangouts episode 183, PVA and Cardboard.
That's right, today's episode we're going to be taking a look at how to 3D print with PVA to 3D print a D20 inside of a D20 inside of a dodecahedron.
We got a lot of cardboard prototype things.
That's right, it's cardboard fever. All that and more on 3D Hangouts.
You guessed it. Let's run the intro. Like this.
Excellent.
Hey, what's up everybody? Welcome back to another 3D Hangouts. My name is Noah Ruiz. I'm a designer here at Adafruit, and joining me every week is my brother Pedro.
What's up everybody, I'm Pedro Ruiz, Creative Tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
That's right, this show we combine 3D printing and DIY electronics to make inspirational projects for you folks. Thank you guys so much for joining us. This is episode 183. Let's kind of go through some shop tops, or some housekeeping. Yeah, let's do housekeeping real quick. This is, of course, 3D Hangouts. We do the show every Wednesday at 11 a.m. Eastern Time. We still got that going on. Let's go ahead and jump into paying some bills. How about some water bills using coupon code, you guessed it, WATER. That's today's coupon code. So if you want to check out anything in the shop, everything is up for grabs using the coupon code, except for gift certificates and subscriptions for $8. Alrighty, but we do have some cool freebie deals going on. Adafruit.com/free gives you all the details on what is free. We have stuff, so check it out, Adafruit.com/free. We also have some cool shipping deals. We got same-day delivery for fine folks in New York City. Certain zip codes apply. Go to the website for that stuff, for other details on that. We also have some newsletters. We got Adafruit Daily. That's the daily digest of all sorts of categories that you got to opt into. Go to adafruitdaily.com. That's the website. It's separate from your account. We got another one for you that's a product-based one. This is the adafruit.com/newsletter. Once a week newsletter, all the stuff that are in the products, that are the weekly products, it's in that newsletter. So if you want it in your inbox, go to adafruit.com/newsletter for that. Hanging out in the Discord chat room all week long. Shout out to all the folks that are in there hanging out, sharing their projects, getting project help for all the community members. Also, we have a CircuitPython meeting on the Discord channel.
Every Monday at 2 p.m. Eastern Standard Time.
That's right.
Dan, Scott, Katney, Carter, and everybody in the community gets to go over all of the really wonderful...
all the stuff they're working on, yeah.
All the behind the scenes, all the code that's being committed. So definitely check it out. We were there this week. We occasionally show up and we're going to have a CircuitPython based project.
Yep. And next week will be the first public... because Scott's been recording them for the past, I want to say like 2 months, but they've been privately listed just because he wants to really fine-tune the format and the script. So shout out to Scott for doing that so well every week. And then next week is going to be finally public. So get get used to it. It's more like a podcast style, I think. There's a little bit of visuals,
It's
very
a podcast,
little bit of visuals.
some visuals because of the
I would
Discord.
just
We're able to
listen,
put
'cause
links in
everything
there.
is-
And
yeah.
it's also like a show and tell since you're able to participate and talk about any
working on,
of pull requests you might have or
any
any
Cypher
projects
Python
you're working
stuff,
on.
yeah.
You also get help in the live in the chat room there as well.
Yeah.
Really good format we may take on one of these days where it's a really good way to have the audio so people are able to
Yeah.
interact in some form
That's
that
right.
way.
And you get to see things like this, the Blinka cake.
Yes.
Yeah.
And we talk about some behind the scenes stuff we've been working on as well.
Yeah.
The show can have just so much stuff in it, so there's always overflow of other unrelated info we can talk about there as well. So definitely stop by every Monday, 2 p.m. Eastern Standard Time.
That's
to a
right.
Python meeting on Discord.
That's right. I am trying to fix the YouTube chat. Looks like it's down. It got stuck in the state where I can't quite fix it.
Yes, shout out to the
So-
snake cake that PT had
Yeah.
for the CircuitPython team that was there in New York in the office last week. If you listen to the show, you could see what it actually tasted like. I think there's actually links to the unlisted video if you guys want to take a listen to that. If you guys want to be crafty and search around for that, you can find out whether Blinka bled when
Come on.
when you cut into the cake. What was the flavor of the cake? If you all want to find that out, definitely look for that.
I fixed it.
Woohoo!
Oh my gosh.
CSS win.
That's so funny. Give it another second. There we go.
Woohoo!
You know, we might get rid of the sidebar chat because YouTube now has a live replay chat.
Our only dilemma now is just rearranging the layout.
That's the thing. It's like, well, I have this template.
I kind of
and
like
every
it because
time I
you can
break
like
it-
see it right there.
I
right
do
when we
too.
look at it.
It's a helpful monitor for us because we only have one monitor here in front of us. But I don't know. We may change things. Live shows are really tough, man. Yeah, I'm surprised we're at 183.
Another shout out for that cake. Maybe we'll
Yeah.
make some cupcakes.
So
as
hey,
well.
everybody in the chat room, I can see you now. I can see your chats here because I gotta have windows everywhere. So okay, let's
go ahead and jump into this week's project.
ahead of you there. All right. So do you want to do the overhead or jump into the learning guide? Let me have the learning guide linked first, and then we can jump into the overhead.
This week's project was inspired by a really cool CNC D20 inside of a D20 that Phil found from fine folks over at
I've seen this
Autodesk
quite a bit.
Pier 9. It's
Yeah.
like a 9-axis mill that they were using to mill out this really heavy metal.
Yeah, it's a D20 side of a D20, and it's milled out of aluminum. Yeah.
Actually,
It's
the
very
one
difficult to do, I think.
Yeah.
You can only kind of do that with a 9 or 6-axis mill, whatever. Actually, more than 3.
Yeah.
So this got us thinking, and got Phil thinking, like, hey, why don't you guys make a D20 inside of a D20, 3D print it? And we're like, yeah, that's a cool idea. You know what? This might be a really good test for PVA filament. So PVA filament is a filament specifically designed to dissolve in water. And what is that good for? This is really good for making support material, right? So what better way to test out the PVA with something that you can't print with regular PLA support material. If you print this with regular PLA support material, you totally can, it totally works, but the hard part comes in removing
Removal.
the support material. How do you get in there without breaking the part, right?
You actually tried this just as
I
a
did.
test, and you immediately broke it, like right away.
Even with the thickness of like 4 millimeters of those little frames, it's still easy to break, right? Because your tool can't fit in there. So how do you do this, right? So tell me, how did you do it?
So we busted out the PVA settings to fine tune. So that was another one of the tests as well. We jump into the learning guide. We can take a look at some of the settings that we use for that.
Yeah, and another good point John just made, PVA, you kind of need a dual extruder to do this. Because if you just
Absolutely,
print
yeah.
with PVA, your whole thing's going to dissolve.
Yeah, so the way this is printed, that they're all right in the middle of the object, and then it just prints right into the air. And
Yeah.
as you can see, you can kind of see the close-up
Details.
there
I can
of
do
the
a quick
detail.
macro shot here. Focus.
So we are using
Up
the
there.
0.25 millimeter nozzle to get very fine details, printing at 100 microns. And then the PVA is using the specialized 0.4 millimeter BB nozzle for that. Now, I don't know if any other manufacturers have a specific
print core?
Nozzle.
Or just a print core in general, like
Yeah.
a swappable print head.
A nozzle
That's on the
specifically
market right now, because
Yeah.
there might be some stuff in development. So yeah, so this is the Ultimaker 3 that we've been using.
Yeah,
to
I
do
tried
dual
this out
extrusion.
on the Sigma a while back before, but I wasn't able to get the type of clean prints I was able to get out of these. Maybe it was the nozzle specific.
Yeah, maybe
but
that's
in
why
any,
the print core is specifically designed for PVA material.
Yeah, but in any case, we were able to get some really good qualities out of this. If we jump into the guide.
Yeah, so if you head on over to Adafruit, learn.adafruit.com, you can see the guide. What you're just showing here, this is what the print looks like out of the printer.
Yeah, this would be
completely
next to
engulfed in
impossible to
PVA.
remove. Yeah, if it was just
It's
regular
really dense
sports
as well. So cutting through it gets kind of denser as you
on the
as you-
inside. Yeah, this
as
is
you
actually
cut it,
a
yeah.
pretty low density for the PVA, just to save up on that and increase the print speed. So let's go ahead and look at the learning guide for that. If anything, the main takeaway you can get from this is our print profiles that we put up on GitHub.
Yes.
If anybody has any printers that they use, you've dialed in some really good settings, please share those with us. Specifically, we're looking for the Prusa print profiles, since we'll be getting one in. We want to be able to have some tested profile settings that we can use right away. So
Yeah,
we'll definitely contribute to that. The link is in the 3D printing part.
Yeah,
Since this is just overview, just describing what PLA is, or PVA is. It's a dissolvable filament used for scaffolding, yada yada. You could probably tell from all that already.
We just covered that. That's why we did the overhead. All right, we talked about the print cores.
You can get a download link or the Fusion 360 files if you want to adjust any of the settings for the framing. If you want to make it even smaller than this. Maybe if you have like a smaller nozzle, you want to test that out.
Overhead?
Oh no, this is fine.
All right, so yeah, you got some STL to download. You can scale it as you want. There's 2 different models, right?
There are 2 different models. There is one that is D20 inside Dodeca, and then the actual one that Phil found that was CNC'd was just a D20 inside of a D20 frame. So this one should be a little bit more easier to print, less PVA, since the way I did the model for this one, it's a little bit closer to the ground, so you're using very minimal PVA just to get the separator away from the actual main frame that's inside of.
Talk about scaling. This is 100%, the blue one that you see there. And if
100%.
you scale it down to 50%, this is about 50%. Is that right? Okay, so it's a little bit smaller. Definitely takes less time to print.
Yeah, and you can go down to 25% as well. And the framing should stay pretty good as well. I think it drops down to about a 2mm thickness, so it shouldn't be so fragile.
Yep, and good question, John. What is the 3D printer that made these miraculous prints? That's definitely the Ultimaker 3. This is the Ultimaker 3. It's kind of like Ultimaker's flagship product right now. It's the dual extruder right there. And it's got the camera and all this great stuff. Okay, so back over to the Learn Guide. Excuse me. So here's the profiles on GitHub. These are for Cura. Just want to say that out. Cura is the slicer. It's a free piece of software developed by Ultimaker.
Yeah, but if you go ahead and click on our GitHub link to that, you can see that we have a massive amount of different printers. If you jump one folder out to the main printer profile section, you can see every single printer that Adafruit has stocked in the past 6 years or whatnot. Everything from Orions to Lulzbots to deprecated ones like the Type A or the FlashForge, Sigma printer bots, Simple Metal, the Play, the Plus.
Yep.
We got a bunch of different printer profiles up there.
Yep. Yeah, it's a very pricey printer. It's definitely aimed towards industrial
It's mainly
designers.
for engineering, yeah.
And it's great to have it, to be able to have it and use it, because we talk about reliability, we talk about the quality of the print.
Especially for this show,
worth
where the main focus is on the actual project, not on fixing a printer, building a printer.
Okay.
Good question. Liz was asking if we got the M3 or the MK3
The
kit
Prusa?
or build.
Okay,
we got a full build, specifically for doing all the multi-material testing. So definitely share any profiles, and we'll set up if we'll do a fork
there's still
or something like that.
To,
so you can get credit for that. Yeah. So upload to your GitHub, and we'll fork it over add it to this, I would like to say, a nice extensive repository of really good profiles that have been tested on actual projects.
Yeah, a lot of them are Simplify 3D and Cura.
Yeah, there's a nice mix of
mainly
them.
those two. Yeah. Another question: are we getting a S5? Maybe.
S5, yeah, we did request one.
Yep, we'll see. We'll let you guys know. But
yeah.
Right now, it's kind of.
I think they're still. I think they're still trying to get those out.
Yeah,
they are at the show right now.
Yeah.
So they're.
You'll probably see other folks in the YouTube community do reviews and things.
Mm-hmm.
Maybe Joel, maybe Maker's Muse, maybe Tom. Those
I got to start modeling what the main project that we pitched for them for this, which was the chainsaw guardian sword. I forget the name of it.
We definitely want to do something where it utilizes the bigger build volume.
Yeah.
Right? Okay. Cool. Awesome. All right. So we got some printer profiles. Those are weird to say.
Check them out.
Let's talk about how do you calibrate dual extruders.
So
every printer has its own method.
So you definitely want to calibrate, especially if you're if you were previously using a different nozzle. If you're switching over to printing something that's going to use a different nozzle size, you want to make sure you calibrate it, just because of the differences and tolerances when you screw a nozzle in. Even with the Ultimaker ones, where you just simply just inserting it into a snap-on part. There could be variations in the way that the nozzle was manufactured or something like that. So you just want to make sure that they all align properly. It just prints, you said really good, just 2 lines to make sure that both nozzles are aligned to each other.
Yeah, so each printer has its own method. Some of them have onboard screens that gives you a nice rundown of how it works, which is really nice.
Yeah, the Sigma printers and the Ultimakers have a nice little walkthrough on board the menu screen, so you don't have to have a laptop or phone that you keep switching between. It tells you right on the printer like what to do, when to do it.
Yeah, so the Ultimaker 3 comes with this nice little handy sheet, and the thing is that it'll print out these series of lines, right? They have kind of notches. These little lines, it's one line thick, and then it'll do that to the second nozzle as well, going on the X and the Y. And then what it'll do is, after that print's done, you basically take off the glass, right? This is really cool, and then you actually overlay it on top of that sheet, right? The sheet with the X and the Y on it, and that sheet will basically give you precise measurements and tell you what offset. You have to choose which offset looks good to you, which one looks more lined up. So that's how you calibrate the X and the Y offset for those 2 nozzles.
Yeah.
It's kind of neat.
It's about a 20-minute process, but it will definitely save you, especially if you're, especially with these prints, since they take so long to print.
Now, do you have to do it every time you switch out the combination of nozzles?
Probably, just in case that you inserted them in a different, especially with us, since we have multiple sizes that are different sizes, same size of different print core, so there could be variations between them. So just in case.
Yeah, you definitely want to calibrate them.
The other thing you want to do is make sure that you also do a cold pull or a clean pull, which is when you clean the filament by inserting it, letting it cool down, and then using pliers to rip it out so it can sort of solidify with any gunk that might be inside there that just got too clogged to extrude out of the nozzle. So you want to make sure that they're all nice and clean.
And that's one of the things I like about the Ultimaker. It actually does that after every print. It waits until it gets cold, like 190 or less, and then it'll retract, and then it'll park itself without you having to do anything, because it knows, hey,
just in the firmware.
This is gonna.
You want to do your additional clean. Just to make sure you get everything out, because it's not heating up.
Right.
And then
I'm just trying to say, like, hey man, there's a reason why this printer is pretty pricey. It's got a lot of smarts built into it. Not a lot, but enough to like reduce some of the cleanup and maintenance, and that's kind of what it's about.
Yep. So calibrate nozzles, clean your nozzles. Moving on to the
series and episodes on just that, but
moving on to
very specific.
Moving on to the actual print settings, we're using 0.1 millimeter layer height to get all of the final little details inside of the numbers for the D20. We're also using a 0.4 millimeter nozzle for the PVA, also at 100 microns.
Yeah, so there isn't a 0.25 BB nozzle.
Yeah, it might be too.
Do you want to tell us about the nozzle variations? You can bring them up. I mean, if you want, I'm not sure.
I think we've already covered it.
Okay.
Moving on to the highlight settings. There were some things I needed to tweak inside of the PVA profile for this, and I have them highlighted in the guide here. One of the first ones is the retraction amount. This could be used for any print, not just PVA, so this is why I wanted to highlight this. You can turn down the maximum retraction count. The default was around 25, which grounded up the PVA pretty well because of, all of the islands that it has to print because of all the, the framing that's around there. So you want to drop that down just so you have minimal grinding of the filament. You also want to enable your prime tower, primarily so you can be sure that both printers are nice and primed. You don't want to have any under extrusion, especially with such long print. Also, turning on the circular prime tower, we found that there was a lot less jerks in terms of the movement of the head, especially when doing the wiping.
Okay.
And then the other thing you want to do too for the PVA, you want to increase the purge volume to 1, just so it extrudes more. Make sure that you don't have any under extrusion in the PVA because it can heat away while the other nozzle is printing. And then the other thing too is enabling the brim to print on the inside and on the outside of the towers, so it doesn't get knocked off when it's doing a wipe. And the funny thing to turn this on is that you have to enable the option to disable it. Yeah. So inside of Cura,
a lot of things get hidden in Cura because there's a billion settings, and you don't want to.
So next to each main title for the settings on the drop down, a little icon will appear, a little cog icon. If you click on that, it'll take you to the full list of settings for all of the profile settings for that. And you can do a search there, and then you have to actually enable the visibility for the print only on outside, so you can disable it.
It sounds very confusing without actually seeing it, but hey.
You can kind of see it here. Yeah.
There's no cog wheel here, but it shows up when you actually
roll over it.
It's one of those weird things. UI. Okay.
So that was one of the main, or a couple of the main highlights. If you go ahead and download the profile, they are readable as a text file, so you can actually go through and look.
XML?
It's an XML, so you can take a look at all the settings for that.
Cool. It's just some other basic ones, like usually we talk about speed and temperature.
Yeah, so the because it's 100 microns and the smaller 0.25 mil nozzle, we're printing at 40 millimeters a second, so a little bit slower than usual. And the PVA is actually printed at 35 millimeters a second, so a tad bit slower than usual as well. That's just to make sure that we have adequate extrusion and that it doesn't have to print as fast to make any details.
Yeah.
So we're not cutting corners in terms of getting the quality out.
Okay.
Moving on to dissolving PVA, when we did some search for this, we were surprised that nobody really made any guides or full detailed lists on this.
You just throw it in water. That's all you do.
Yeah. So going on to that section in the guide.
But you do just throw it in water, right?
Sort of.
Sort of. Okay.
Yeah. To start off, you definitely want to use clean, lukewarm water. Use a little bit hotter, but not so hot that it's gonna soften the PVA. Just be aware of that. You want to make sure that you're using a tanker that is able to fully submerge your part. If it starts floating up, because a couple of the smaller ones did, you can put something on top. I just put like a plate over it so it wouldn't come up to the surface of the water.
Yeah. What kind of water did you use?
We're just using
water or versus osmosis water?
Regular tap water. Yeah.
Okay.
So
regular tap water.
The other tip too is to remove as much of the outer PVA structures as you can, just to speed up the dissolving.
You could, yeah, but again, it's a little risky because
don't remove the stuff on the inside if you can't get to it. But if you can easily pull off the filament that's on the outside,
or you can just throw it in there like we did, the whole thing.
You can do that as well. Yeah. So this is going to take about
a day
and a half.
It takes a while.
But in that time, you want to be able to make sure that you're
changing the water out,
agitating. So if you scroll down, you actually used a sonic bath cleaner to speed that up. If your part's able to fit inside of it, definitely a good way to go for that.
You can leave it open and have it just do one side. But yeah, ionizes the water and shakes it microscopically? No, atomically? Yeah, that's how the sonic baths work, I guess. I'm not sure. But anyway, it worked here in this case. I left it on for many different cycles. It goes up to like 3 minutes of a cycle and then it stops. Actually warms the water a little bit, so it keeps the water warm for you, which I found was pretty cool. Yeah, it still took, half a day to do.
Yeah.
So it looks like what you can do to speed it up is just kind of scrape it off a little bit gently with a spudger or something like it.
Yeah, as it starts to turn to sludge, you can definitely use a small picking tool like a spudger.
Mm-hmm.
Spelled that wrong in there.
That's fine.
To sort of scrape that off, and that's definitely going to speed up time, so the water is able to get to more of the PVA that is, still not dissolved. So that definitely helps. You want to clean out your water. And somebody asked on the YouTube comments too, what do you do with that water? You're able to put it down the drain.
Throw it down the drain.
So all of the PVA is actually going to sink to the bottom. So you can sort of strain that out when you dump out the water to replace it. Just don't dump the water that's all the way at the bottom. You can use a paper towel to sort of scrape that off the bottom and throw that away, just so you don't get any clogs in your drain.
Yeah, I mean, it's PVA, it's glue. So
you'd have to use like hot water to, sort of dissolve it out, but
yeah, you don't
it's
want
more
it
easier
to get
to
clogged with glue, so you might as well scrape it out, throw it away.
Mm-hmm. So that is safe if, as long as you don't, throw the sludge down the drain as well.
I think it's still cleaner than toxic resin, right?
Oh, absolutely, yeah, because you're using alcohol.
You can actually touch it with your hands.
Yeah.
You can't. You could do that with resin, but you probably shouldn't.
Mm-hmm. Another thing that I was doing too was using the little sprayer thing on the faucet to sort of help
kind of get a little bit of pressure there, right?
Exactly.
Kind of knock off some bits here and there.
Mm-hmm. And then you can toss it back into fresh, warm water. You can repeat this like 2 or 3 times. You can repeat it
as many times as you want. We were kind of playing around with different.
There's still a little bit left on this one, so you could actually toss this back in and have it dissolve even more.
Yeah, okay. Because I think some of these we didn't use the ultrasonic bath, so maybe use that as like a final step.
Yeah.
Does the flowage float or sink? Yep, it sinks.
Sinks.
Definitely sinks in the water. If it doesn't, it's a witch. Yeah. Everybody has a septic. Well, some people have septic systems, and you gotta be careful what you dispose of in there.
Exactly. Yeah.
Put some water oil down there.
Yeah. So as it starts dissolving, you see the sludge on there, the water on top, and you can run your hands through it, and it's not sticky at all. But if you run your hands all the way down to the bottom of the sludge, that is going to be all nice and sticky. So the top water is safe to strain away. Moving on to, I think that's pretty much it. Yeah, after you put it in a couple times, you should wind up with a completely clean part. You can, and the really good settings that you can definitely save out
by not leaving it in the sun. Don't do that.
Oh yeah,
it's PLA. It'll melt.
Just pat it down with paper towel on that.
Let it sit there. Yeah, shake it around and stuff.
Yeah, that's pretty much it. Yeah, make sure to save all your settings. So you can utilize those for different prints. Definitely save those out. And that's actually what we uploaded to the GitHub page for the print profiles.
Cool. I saw one of the questions like, why'd you use a tower? I thought you could just print it without a tower.
So I did do
waste,
that.
Right? This is waste.
I did do that, but I would get under extrusion on the PVA, and then we were getting contamination because of, if you take a look at this.
It doesn't look like there's much PVA in this prime tower.
And that's exactly why you raise the volume for priming on PVA to 1. I don't know what the value for 1 is. The unit, but the default is 0.5. So it's definitely extruding more when priming the tower. So it definitely helps. As you can see, there's all the gaps where the PVA would have been. And it's also serving as a wipe for both nozzles, so you don't get into that contamination.
Right. It's kind of nice because when I think about something like the Sigma BCN 3D with their dual extruders, the way they purge, the way to handle this is they have these little retainer buckets that are parks, and it extrudes out a little bit of material. You end up with a bunch of material. This is actually nice and consistent. It's in a block that I could easily toss. So it's kind of a nice alternative to purge buckets. Yeah?
Yep.
Cool. All right. And it's not that big. It's not that much of a waste. It's probably less material than... Maybe it's the same. I'm not sure. Definitely worth it, though, if you want geometry like that.
Again, a call out if you have any printer profiles, especially with dual extrusion or multi-materials, or just regular, really good PLA print settings,
Right.
definitely send us a GitHub.
Yeah, we
For
really
that.
didn't have any projects that really utilized PVA. Where it's like, yeah, you could throw PVA on it, but it needs to kind of make sense, right? And this is the best thing we come up with that was kind of doable, right?
Yeah, yeah.
Okay, because I kind of already had this design, and I just did a little bit of modifications to put them together. All designed in Fusion 360. I actually have some tutorials on how to design a D20 and a dodecahedron.
It actually took a lot of work between you and Phil
Little
B
bit.
figuring out the geometry for that.
Yeah, a little bit.
So that's this week's project, PVA settings, and of course a really cool model you can play with once you're done with those.
Cool.
If you guys want to use coupon code to get any of the materials, of course printer and that jazz, use coupon code WATER, get 10% off.
Yeah, we might stock some
Expires.
PVA. We're looking into different suppliers.
And we're looking at PVA, we're going to get wood fill back in.
It's a little bit more costly because maybe the manufacturing of PVA is a little bit more difficult.
I only saw one manufacturer.
Another thing
that-
to note is PVA likes to absorb moisture, so you definitely want to have it in a dry box. Ultimaker actually ships their material with an extra baggie, an extra Ziploc bag with desiccants, right, to kind of absorb the moisture. That's kind of nice.
Moving on to this week's prototyping.
Okay.
What have we been prototyping? You want to go
flip
first,
behind
or
me
you
a
want
bit.
me to go?
Yeah, so over the weekend we got ourselves a Nintendo Labo, like the rest of the world did, it feels like. Everybody's getting their
It has been
Nintendo
a cardboard
Labo.
party going on all week.
Okay, yeah, so Nintendo Labo, check it out. It's a nice little add-on to the Nintendo Switch. Allows you to interact with physical shapes, physical add-ons, and take inputs and things like that. So we're trying to come up with some electronic projects using cardboard and 3D printed bits. So one of the first things we did was try to make some fasteners for cardboard. So there's already an existing product called Make Do. We actually sell those in the Adafruit shop. So I wanted to make a Make Do compatible kind of mounts for the Circuit Playground Express. So you can see here I came up with this little mounting thing for even micro servos and such. Very, very simple. They're supposed to be Make Do compatibles. But then as I started working with it, and even John Park mentioned too, that it's kind of, the Make Do's, the threading on there, and they're kind of specific, and they don't really work well for joints, right? For like free moving joints. So I went ahead and designed my own Make Do kind of screw fastener with heck nuts and cap nuts, just to kind of make this thing. So that's what we came up with. So is it this one? Sorry, I'm trying to figure out which video is which. I got down on some cardboard and started making some scissors mechanism, sort of like your expansion frame, or I guess that's what you call it, a scissor mechanism. These hinges, linkable hinges. So I made myself a little template, 3D printed myself a template, and I cut some strips of cardboard. That way I can create this scissor mechanism. And these holes are all precisely, because I made in Fusion, so it's precisely symmetrical. And then I started figuring out some ways to drill holes, make holes into cardboard. Using a drill really isn't the best because it kind of makes sloppy holes. Poking holes is another option. But then I started playing around with different sanding bits, pointy tips using a Dremel. And that seemed to work pretty well. If anybody has any good ideas, let me know. I should probably look that up. The best way to make clean circles. So yeah, I'm using the Dremel tool, this kind of sanding bit that has a pointy edge. That way I can kind of poke myself into the hole. And what it does is it actually makes these really clean holes where it kind of fuses the inside of the hole, which is great for screws, right? Because then you can thread through that and it's a little bit more stronger. Another thing I found was I really haven't worked with cardboard a lot, so just learning how to cut against the corrugated grain. It's kind of like wood, right? You got to cut along the grain to get a stronger part. So that's what I did with the cardboard. So I cut a bunch of these, made a lot of holes, which may or may not be the right way to do it, but it worked out for me. And then I put them together to make the scissors mechanism. And what do I have, like 8 of them in here, or 12? I don't know, probably 8. Yeah, so I made a good handful, making sure that they're all the same size. Then I printed a bunch of these little 3D printed fasteners, screw things. They have a pretty custom thread to them. And the section size is fitted so that it works on most 3D printers with a regular nozzle and regular layer heights. It's definitely following. You can use the make-do little
tools to screw that in. And this is the modified one that has the optimized spacing, so you can actually use them as hinges.
That's
so
right.
They're not going to unscrew themselves. And because it is 3D printed, we are able to control the density of it by lowering the infill, so it's not as heavy with the, 2-ply, 4-ply, double face standard cardboard. Or what is it, the A3
Amazon boxes. So I took an Amazon box and came up with this.
Mm-hmm.
So it's pretty cool. Made some scissor mechanism, linkable hinges with cardboard and 3D printed bits. So you get this nice free-flowing joints. I also got these cap nuts as well that kind of cap off the thread there. Adds a little bit of weight to it, so you kind of don't need them, but I still have them if you want to tighten up and make a tighter fit to it. As you can see here, I got more of a tight fit, so if you wanted to actually stay open, you can add those nuts and make it a little bit more secured.
Again, adjustable in terms of density, use like 0% infill, so it lowers the weight of it even more.
Now the next step is to, of course, add a servo to it, make it remote control with the Circuit Playground Express, which I kind of already did. I'm working on it. I got it back there, but I'll show that for next week. Man, let me tell you, making that template was the best thing I did, because when I started, I was just like, I just fudged everything,
make sure it's
and
precise,
the hinge was just like so sloppy. So just working with that all weekend, like just figuring out like how do I cut this
of making templates. When you guys are playing with the Nintendo Labo, I did take photos of every single
every sheet.
I took a picture of it, so I can go back, trace all of that out, and 3D print like templates to make even more in case I mess these up. Because that's one of the funniest things about this. You know, you're paying $70 for some cardboard, and if you accidentally rip it or if it gets moisture on it, you're pretty much out a small little part that I think they only give you one of. So definitely make backups of your parts so you can later make more.
Cool.
And did you have something for the overhead?
Yeah, I have this video. So while I was working on cardboard, Paige was also working on cardboard, but with the Nintendo Labo templates. So here's the finished product, sort of.
So I've never seen these types of cardboard inputs with the rubber bands for using like force feedback or the retraction on that's going on that key. I forget what they call these parts, but yeah, if you jump over to the overhead. Turn this guy on.
Yeah. So it looks like you got some copper tape and some silicone coated wires, and kind of made like a open and closed switch looking thing, so you can plug this directly into the Circuit Playground to trigger some NeoPixel animations or some sound effects. So one of the goals is to make use of the Nintendo Labo cardboard kits without the switch. You can also have the switch as well, but
So definitely going to be utilizing. You can see there, it's just. Take this out of here. It's just 2 pieces of copper tape making contact to close that. Boop. There you go. Oh, a lot of cardboard is falling apart here.
Yes. So I'm going to answer some questions while you kind of show that off. So John Park is suggesting a paper punch. Yes, I have one on order. I'm hoping that it won't bend the core, bend the grain, because it seems like every time I try to force a hole into cardboard, it just ends up bending, and then it's like throwaway because it's no longer strong anymore. So that's a good idea. And hopefully a bigger punch, like there's thick versions of punches. So that's one option. Also got a step bit that's coming in. Making a 3D print template is genius. Yeah, I thought that was a cool idea.
Yeah, so this is what really impressed me here, using the use of the rubber bands inside here to add the sort of the interactivity to this. So definitely cool ways to interact with the Circuit Playground in that sense. So definitely going to be making, tracing out the template to remake these. Yeah,
tell me about the build process. What was that like?
It's pretty much just using jumper cables so you can easily disconnect these.
Oh,
so if you want to have
the build Labo.
Oh, I have.
Very thorough. It was a lot of fun. I built
all the work went into all that animation on how to do all the build process for each step. So there's a ton of work that went into that. So they did a good job on that. The actual games for your build are subpar.
They're meant to be a sort of this lab, right? They're meant to be experimental demos, really, to get people's ideas cooking.
Yeah.
Because it's hard to come up with. Is this? Yeah, this is the one I made. Yeah. So I'm trying to figure out how to get this to be a potentiometer controller. So basically, I 3D printed a replacement cap here that will house, or that will secure a potentiometer. So that way you can spin the potentiometer, but then I have to create some sort of way to hold the potentiometer down so that this turns just the top and not the whole potentiometer.
Which you've already started to do.
Crank, that I put together. And all the instructions, again, are really, really nice and thorough. And the way they created their video / animation of the build in the Nintendo Switch is genius. That stuff is really cool. And the way this works is it has this little tab here that touches another piece of cardboard down there. Yeah, so there's several pieces that get made into this. There's like this little lock mechanism here that comes out. It's really cool. If you want to get the good, get one. That's all I can say. Like get a Nintendo Switch, just for the idea and the building. It feels a lot like building a Lego piece, but bigger and like more complicated a little bit. I don't know.
In terms of all the folds, yeah.
Yeah, it'd be a cool base for a optical rotary encoder.
This is actually exactly what this is with the infrared.
These are reflective pieces of tape that the infrared camera on the Switch controllers, the Joy-Cons themselves, read. So you have to manually put all these stickers everywhere.
And they're all over on
just
all of these.
These are not stickers. These are like printed on there, and they're everywhere, as you can see.
They're on all these parts there.
It's pretty
So
cool.
a really cool way to do
we were
that.
quite impressed with it. And Cardboard really took over the whole weekend. Like,
oh my god,
we had projects that we had to literally just stop because it's like, all right, focus on this.
I've modeled nothing.
Also, spoiler or upcoming thing, Adabox 08 is heavily based on Cardboard projects, so the whole team is the whole creative team is working on coming up with some project ideas using Circuit Playground Express and Cardboard.
Yes.
And make code. You put this together and make code, didn't you? Yeah, very cool. Jumper cables.
Jumper cables, you can easily swap these out because the main purpose behind this is each...
Modular.
Yeah, it's modular, especially for the game, so you can stick it on the bottom or the right or left side, and it'll change what's actually interacting with the actual game on the Switch. Yeah. So that's pretty cool.
We still have quite a few kits that we haven't built yet.
Yeah.
This is just like the main big one we built. We built this one in the motorcycle steering thing. We still got to build the piano, which I really want to build.
Yeah.
Maybe this weekend.
Yeah, in terms of getting ideas, though, this was a really good one. Actually, Gavin picked this one.
Yeah,
to
we
build
asked
first.
him, like, hey, what do you ask a 4-year-old? Hey, what do you want to build? Surely he's going to want the motorcycle, the piano. No, I want the house.
Which was good in our case, so we can so we can definitely
cool.
figure out these inputs.
The Nintendo has all these pictures. Like, we showed him the box, and he looks at it a little bit confused. Like, is this Lego? What is this? What? Oh, it's a house. Cool, I know that. It's like, I don't think he's into pianos, but he's into the house. Isn't that? You see, it's like it can reach every kid's. That's why they have all these different shapes on the box. It's like at least one kid will pick something.
Yeah. So Cardboard's going to be the hero for this with a little bit of 3D printed parts, but because there is this such thing as wood fill, you can actually 3D print what is essentially cardboard with a printer. So shout out to John Badair, who made this really cool.
John Badair on Instagram, Twitter, and beyond.
Who made this really cool, like a remake of the Critter project for the Nintendo Labo.
Yeah, this is on Thingiverse right now.
So
did you plug that in wrong? Is it no?
I don't think I did.
Okay.
Is this? How do I get back into this?
I don't know how to use the Nintendo Switch. It says right on there, tap 3 times.
Goes. Connect.
Do you want me to do it for you?
Yes.
It's like, oh, I'm part of the show.
No. Playing.
There you go.
No,
connect it. There you go. Hit the button. The Switch is telling you, hey, I'm not controlled yet, so tap one of the buttons. There you go.
There we go. So he did mention that there were some difficulties with the PLA-only version of this. It wasn't the frequencies you had to get just right to move properly. So I was thinking, oh, maybe the wood fill PLA would have like some dampening in it because of the wood fibers that are in there.
Really? He said that? I didn't even...
No, I thought that.
No. I mean, John Park was... Or no, sorry.
John Badair said that, yeah. He was saying that he has it in the Thingiverse link, and it'll go out as a post tomorrow as well. If you go to our sheets, it should be in there as well. But this works pretty well. The frequency for this one is just 167 hertz, and that works pretty well. Of course, this is 3D printed wood fill.
Yeah, yeah.
I mean, there's not much to look at. It's just two buttons.
I'm impressed that you can see a live feed of the IR camera.
Oh, the IR camera. Yeah.
Oh, there's a camera in there? Yes.
Yep, here it is.
That's great.
See
That's
my
how
face
it
there.
sees all the reflective dots and things.
You see that?
Yeah. It's so high quality.
It's like 100 by 100 pixels or something, but yeah, I'm surprised that there is an IR camera in there.
What
it should be, that's last week. Go to this week.
Oh, sorry.
And it should be the 130. There's the Thingiverse link for that.
Cool. So
you guys can test this out yourself. I'm just using a 0.2 millimeter layer height, 0.35 extrusion width, just to make sure that there is enough tolerances for the Joy-Cons actually fit nicely into the slots. That seems to be the biggest tolerance troubles with making a Joy-Con little slider thing, but worked out really well.
Here's a comment from John Park saying that the cardboard one that he built emphasizes that they needed to have some slop in the fitting so that they could vibrate enough. Yeah,
okay.
So it's not the more slop the better.
Maybe
it's vibrating the whole body.
Yeah,
it is slow. It's a slow moving robot.
Yeah, it's pretty slow.
Yeah,
I'll take a look at increasing the size of the slot, because we're definitely going to take the geometries from this and build our very own Hans.
Yeah, we're
or
going
a
to build
5 timer. Since this is perfect,
an IC.
Perfect IC shape already. So we'll add some little googly eyes and all that snazzy jazz. And of course, the other thing too, when we start building all these, rebuilding these as templates, because Fusion 360 has this really neat tool via the sheet modeling environment, sheet metal workspace, you are actually able to model something and then unfold it.
Yep.
So you have a template to make cardboard cutouts.
There's some really great tutorials, mainly one from Tyler Steen, who made a cardboard box and unfolded it.
So we're definitely going to be using those options inside of Fusion to create some very nice cardboard templates that you can 3D print or just 2D print.
Right? Did it see heat? It's all like red. Yeah, look. It's like
that's
red.
Awesome. Whoa.
Look at that.
I guess the closer that you are, yeah. Wow.
The feed is a little slow, but now it's a little bit faster. It's pretty good. Neat. So I can see heat. Of course, it's not red.
Oh, Nintendo pushed the cut files.
No way.
Check that out.
Check that out. We'll link that in the description. John Park just put a link. Loading right now. Looks like it's Japanese.
Yeah, because somebody said that they were actually tracing like screenshots, which I was kind of dreading.
That's awesome. No, maybe he took the DXF from here. Oh. That's what he did. Yeah. That's great. Look at that. You can cut your own.
Very handy.
Yeah.
So we'll definitely utilize those to make, or at least to have the geometry for having the spacing for that.
You can bring in, hopefully you can bring in a DXF for the outline, and then in the sheet metal tools, refold it, or make, use the flange tool to recreate it, basically. It's really cool, especially since the units hopefully are the same, especially with the DXF, you get the same unit.
That's why when I took my pictures, I had a ruler right next to it just so I could have scale.
John Park's like, I was dreading redrawing that too.
Oh my god, yeah. It's a lot of folds.
Yeah, what kind of cameras are in the Nintendo? There's a teardown switch that Ben Heck did that you can check out. I'm not sure.
Oh, yeah,
but from the looks of it, it looks like an IR camera with the, I don't know, something else in it.
20 infill, I don't know what else settings, just regular worked on this. This is going to take... actually, there was support material for the slots because of the way that prints up. Yeah,
there are pretty thin walls.
Right here, they're pretty thin.
Yeah, that's where the
pretty
thing
thin.
is. But it slid in really easily.
Yeah.
So you do want to have a little loose.
I mean, it's like not super tight, but not.
And again,
super
another
loose.
thing you can use in your slicer is like expand. What's it called? Horizontal compensation. That's one.
I'm gonna do it in geometry.
And then you can just change the extruder line width. A little bit
That's probably
lower.
the easiest thing to do.
Yeah, that way you can it'll print a little bit.
Drop it down to like 0.32 for the extrusion width, just so you have more wiggle room in there. But as it is, it doesn't work too bad.
Yeah,
it's okay.
It's not gonna like freaking fly across the room. It's just the haptic motor thing.
But again, this is gonna be a Hans, and And then we'll work on,
more cardboard.
More cardboard stuff, inputs. This is what really had me going, the springy action on this.
Yeah, it's really cool. I wonder if there's wear. Like, oh, I've hit it 300 times.
There's gotta be, yeah. Especially for this one, since it's rotating so much. I'm sure that's...
It still be working.
Well, because this rotates right here, but in any case, it's pretty thick.
The 4-year-old, because he's gonna break it. Oh no, be gentle, it's cardboard. So.
Oh, sweet, yeah. John is saying
cool.
that
The PDFs are proper vectors for the cuts. Yeah.
Very, very cool.
How does it move? Yeah, the motor.
Oh yeah, there's little has a rumble pack or whatever motors that are inside here, jiggling and rumbling around. But super cool. We're taking a look at that. Check out all the.
Right now and started pulling apart the vector files.
Yes, totally.
Cool. Is it scaled 1-to-1?
He said it is.
Sweet. Only metric here.
Oh, thank God.
All right, cool. Well, I think we ran through all of the video stuff. Let's go ahead and jump into...
I think there's still some other stuff, but we'll save it to next week, yeah.
Let's jump into the community makes. We just kind of did shop talk. We should talk about that stuff.
This week's 3D printing time lapses. This is lovely Voronoi Rose.
Yep, little mistake here. It's printed on Ultimaker 2 Plus, as noted in the background. The text is a little bit of a pain to update sometimes.
I know, I updated all the other settings except
the settings, the time it took to print.
So we're using a 0.4mm nozzle here. It's only 0.2 layer height. I should have used the 0.25 with a 100mm layer height, but I wanted to speed it up as it already took about 9 hours, I want to say, based on the camera timestamp for how long time lapse took. It's a nice little design. Voronoi, not too much info on it, but really good job from designer.
Bruno. _Bruno.
Giardo
Very
Bruno.
cool. No supports needed. Voronoi designs are always fun to print. This one just caught your eye and you're like, yeah, I'm going to print this and put a thing on it. This took 11 hours using 0.3 at 100 microns from the looks of it. Yeah, so you get the...
Again, a nice little retraction torture test for your printer. Yeah, they did a pretty good job on the Ultimakers here.
Yeah.
Lots of overhang, and it handled it very well.
Nice and thick, too.
Yeah. Definitely should have been one for Valentine's, but I did not see it then. And a nice little job in the pedal and all that stuff there.
There you go. Nice pedal. Pretty good. No cleanup required.
Actually, there was just a little bit of overhang down here.
Oh.
And that came out really good. You want to test out some Voronoi for getting in your retraction settings dialed in. Get a little print for that. Very cool. Check it out.
Cool. Printed out. Great. Shout out to Thingiverse user _Bruno. Cool. All right.
Moving on to
Community makes.
Community makes this week. We got a lot of really cool makes from everybody in the community. First one is
8-About Head. This is really cool.
So we talked about this when we released the project, but Caroline added motor or servos to the ears.
That's right. Check
as well as command.
Look at this.
And it's really cool code, so it can recognize wave command.
Check it out on
move its ears. Super cool.
Yeah. Thank you, Caroline, for sharing it with us. The code is also on GitHub as well.
If you want to check that out, and if you take a look at the modified model, it looks like it is a servo mounts on the side of the heads. Really cool. Excellent job on that. The servo horn is the ears.
Yeah.
Super cool.
There it is.
Look at that.
It just caps right onto it. Very cool.
Very good remix.
Yeah, awesome. Very cool. Okay, let me pull out the next one from the list. I should have had these loaded, but hey, you know, live show. Hey, somebody made Starman. We did a remix of it from Vectory, who originally made it.
It's a cool little model here.
Where's the files to print the car and Starman separately? I had a plan to purchase car on the gantry. Oh, cool. Yeah. Yeah, sweet. Yeah. Yeah. You know, re-putting it. Slap braiding is always a fun thing to do as well, which is what you did, I think.
Yep.
Okay, next one. This is a remake of the animated flying toaster OLED jewelry project. Was this a trinket? You made this, right, with Phil B?
Mm-hmm.
Phil B did the code.
Yes.
He put together this little Mac-esque enclosure using a trinket and OLED display.
Super cool. That's
That's
good.
pretty neat. Okay. There's this one. Hey, somebody made the slider MK3. This is the motorized camera slider that we use on a weekly. Yeah. This person's making it now, so.
Very cool. Looks like he's getting the belts.
Yeah, the belt
on
tensioners.
there.
Very cool. Yeah, one of my favorite projects because I use it on the weekly. Great camera effects. I'm losing track of where I am, so I might miss one. Another AdaBox or AdaBot.
Hey, this one looks
exactly like the one you did. Yeah, printed in wood fill, I think.
Yep, Hatchbox
on a
wood
Monoprice
PLA.
Ultimate. Hatchbox wood PLA.
That's actually the wood filament that I used for this project.
Yeah.
Very good.
And he shared his own slice settings. You know what?
Sweet.
That's one of the nicest things you can do is share the slice settings. Very cool.
Awesome.
205. Wow. Nice and cold. Okay. Getting down the list. There are some other things I wish I could share right now, but we kind of don't have the links right now. This was a cool one from Chris Schmitz, working on a Trellis speaker, a Trellis soundbox using CircuitPython. He plans to turn it into a Simon type game.
Ooh.
Really, really cool. I'll have this in the blog so you can take a look at it. And he also shared it in the Discord chat room, so I figured I'd share it with you guys. It's
Awesome.
very cool. He has a nice demo of it as well. All right, well, thank you guys so much for sharing your makes with us. You can always share your makes with us on the Discord channel as well. You got the show and tell channel there on Discord, and we'll be chilling there throughout the week as well. Cool. Well, we've made it. We're almost done with the show. Let's end out with a couple of different things. Don't forget, coupon code is WATER. We still got some free deals going on. Tonight, we're going to do the show and tell, which is at 7:30 p.m. Eastern Time with Lamar and Phil and a couple other Adafruit team members. And then shortly after that, at 8 p.m. is Ask an Engineer, a full hour of Lamar and Phil. We're going to talk about some
behind the scenes, some secret products, and of course all the news going on in the maker world.
Yep.
Lots
New
of
products,
exciting things.
maybe some sneak peeks. You can call in the show to win a new product at the end of the show. 3 magic questions. Check it out. Again, it's on the YouTube channel, Wednesday, 8 p.m. Then tomorrow at 3 p.m. to 4 p.m. There's a 4 p.m. to 5 p.m. Eastern Time. John Park. It's John Park's workshop. John Park, you're in the chat room. Just let us know what the time. I somehow always forget every week, but I always tune in. Like, I'm always kind of like doing something and watching John Park in the background. Yeah, so it's fun. John Park.
We're on some really cool synths, so definitely tune in for
work on
that. And of course, coupon code as well,
Chip name.
and all the behind the scenes of some of the cardboard projects he's been working on as well.
That's right. Sorry, I can't hit that button because the chat's broken on that screen. It's so broken there. Well, thank you so much, guys, for joining right on Thursday at 4 p.m. Just remember that, 4 p.m. Thursday.
Type that in as a text
I know,
element over the
I need to rate
that
a text
screen.
element. All right, cool. Don't forget, guys, your orders support all of these lovely people at Adafruit and the remote team as well. So thank you so much for supporting us and supporting your maker habit by buying some stuff. Don't forget.
That's right. We don't have any loans or any venture capital. This is all self-funded. That's why we get to work on some weird projects like
So we can do
this.
some weird things like cardboards and puppets and what cake?
So definitely
Can you
support.
imagine our board of directors being like, dude, you can't make that cake? No way. That's too much money. You're crazy. Yeah. All right, well. We did
Again, coupon code WATER. Thank you all for joining. And we'll see y'all next week and later tonight on the other shows.
Yeah.
Don't forget to
come by.
make a great day.
All right, guys. You said it. Don't forget to make a great day.
Stay tuned for this week's moment of fail.
Okay.
Coming right up.
It's coming right up. What failed this week? Yeah, it's inevitable, man. All right. Bye, guys. Good luck.